All right, in this video, we're going to be looking at the remainder and factor theorems as they relate to a polynomial function, okay? So the remainder theorem requires us to be looking at a polynomial function f, and it says if the function f is being divided by a linear binomial of x minus c, then the remainder from that division process should be equivalent to f of c, okay? So kind of breaking that down, we're saying in the linear binomial that we're dividing by, whatever this number is that's being subtracted from x, if you evaluate the function f with that, the result should be equivalent to the remainder from the division process. Okay, so let's see that at work in this example. Here f is equal to x cubed minus 4x squared minus 5. We want the remainder if that function were to be divided by x minus 3. Okay, so we're going to take the value of 3 and evaluate the function with it. So that would be equivalent to 3 cubed minus 4 times 3 squared minus 5. So that's going to be 27 minus 36 minus 5, or negative 14. Okay, so that negative 14 should in fact be the remainder if I divide f of x by x minus 3. Now let's actually check that with some division, okay? You could use long division, or probably quicker would be synthetic division. Remember, synthetic division only works when you're dividing by a linear binomial where the coefficient on x is 1 and the power on x is 1, and that's exactly what we have here, okay? So recall for synthetic division, if we're dividing by x minus 3, that means we're going to put 3 in the box here. Okay, we're going to put a plus sign with a line, and then next to the box, we're going to put all of our coefficients, including a placeholder of 0 between the negative 4 and the negative 5. So those are all the coefficients from f of x, okay? And then we always start the process off by bringing the first number down, putting it here, take that, multiply it by the value of 3 in the box, write the result here. Negative 4 plus 3 is negative 1. And now the process starts over. Negative 1 times the box value of 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times the box value of 3 is negative 9. Negative 5 plus negative 9 is negative 14. And recall, the last number in synthetic division that you get, that's always your remainder from the division process. So notice how that is in fact equivalent to what we got when we evaluated the function with 3. Okay. All right, so then we can extend this into the factor theorem. Okay, so the factor theorem says if we're working with a polynomial function f, then x minus c is a factor of f of x if and only if f of c equals 0. If and only if f of c equals 0. So see how that relates to the remainder theorem. When we're saying that f of c equals 0, that really means that the remainder from the division between f of x and x minus c has to equal 0. Okay. Also understand this is called the factor theorem, but it also would be leading you to c being a 0 of the function f of x. If x minus c is a factor, then c has to be a 0. Okay. So let's see this one in action. Determine if x minus 1 is a factor of the function f of x equals 2x cubed minus x squared plus 2x minus 3. Okay, so there's two ways you can do this. So the first way would be taking this value that's being subtracted from x and evaluating the function with it. Okay, so 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. That's going to equal 2 minus 1 plus 2 minus 3, which does in fact simplify to 0. Okay, so basically what we're saying here is that yes, x minus 1 is a factor of f of x. Okay. The other way we can do this is with synthetic division, right? And this is where the remainder theorem really can come into play. So basically we're saying that we'd put 1 in the box. My coefficients from f of x are now 2, -1, 2, and -3. Put a plus sign. Bring that 2 down. 2 times 1 is 2. Add 2 and -1 to give me 1. 1 times 1 is 1. 2 plus 1 gives me 3. 3 times 1 is positive 3. 3 and -3 add to 0. So the fact that I got a 0 there tells me that x minus 1 is dividing evenly into the function, and therefore it can be considered a factor, as well as considering 1 as a 0 of the function. Okay?